CloudTrade's Rule System Part 4 Advanced Analytical Capture. Having explained what a rule is and how the rule system uses rules in order to perform basic analytical capture, it's time to introduce three features, each of which, though easy enough to describe, massively change the landscape within which the rule system operates. I.e., these features add a lot of power to the rule system. Once these three features are in place, it will be possible to write rules in a declarative way, rather like defining the grammar which governs an English sentence. That's why our rule system is called Grammatica, and about which declarative programming I will go on more about in the next presentation. But where the limitation of a grammar only applying to where one word follows another has been removed to allow the more general relationship of where one word has a visual association to another, which is the extension to analytical capture which we introduced with our patent. Rules can have parameters. In other words, following on from the example in the last presentation, we could write find contact to take two parameters, one to identify the heading text instead of just looking for contact, and the second to give the name of the Grammatica database variable to read the email from the document into, say supplier contact email or buyer contact email. That rule would now look something like this. Find contact taking two parameters, text and var, where what the rule does is look for the word given by the text as a parameter, then find details as before below text, then carry on looking until it gets a valid email address and stick it in the parameter, the var parameter we've passed in. We could then invoke the rule by saying find contact for a supplier contact, for the word supplier contact and supplier contact email, and so on. Having parameters means you can start writing more general purpose rules and perhaps build up a library of them. That's the sort of thing that we do actually. Rules writers can also produce their own general purpose ones as well if they want. From this follows the second important feature of our rule system. The parameters can also be rules. And that's quite a game changer, but to see exactly how, we'll introduce it a bit at a time. If you go back to that find contact rule which we just had with the two parameters, you notice that step 3 is used to acquire an email address. Although there are built-in rules for doing such a thing, let's assume we've written one ourselves and we've called it read email address, with the var parameter being the variable that we want to read it into. We might equally have written other rules to read other things, such as read a telephone number, or read a postcode, or read a postal address. We could now refine find contact to allow us to use it to read other things rather than email addresses. In other words, add a third parameter, which I've stuck in the middle here, and that third parameter is a rule, the name of the rule. That would allow us to write things like this. Find contact for the supplier contact for their telephone number, or the buyer contact's postcode, or the delivery contact's postal address, or even the one that we did before with the email address. So all reusing that find contact rule. The word details, by the way, which is a find contact, remains the same, it's part of that rule, but we could even pass that as a parameter if we wanted to as well. Passing in simple rules such as that data capture one is one thing. The find contact rule itself could be passed in as a parameter as well. For example, if a customer contact was not defined by customer contact but rather by the fact that it appeared in some whole area where customer details was, we could have a rule called find customer details and actually pass in the whole of that complicated, sophisticated find contact rule, and find a postal address in one case and an email address in the other, or even a telephone number. That means we really can pass in rules and invoke rules within rules. The important thing to realize about this is that the rule that's passed in as a parameter only gets run within the context of the rule that it gets passed into. And that idea of context is very important because it qualifies how a particular rule will be done. It really allows you to think of your rules in two ways. You could have rules which are all about navigating you to the right place, and other rules which are all about picking the data out. The data acquisition rules then are only used within the context of the structure rules, i.e. you pass them in as parameters. And that means that you can now have simpler acquisition rules, just to say capture an email, because your other rules get you to the right place. See, if you wanted that number down here where I illustrated in blue, the bottom right, just following the text number, you can see that numbers following the text number are appearing in all sorts of other places within our document. Trying to actually get to the right one can be really quite of a traditional programming nightmare. There's all sorts of strange logic involved that you would have to try and unpick. With Grammatica, essentially declarative rules, you tackle the problem by defining the high-level structure of the document. The high-level rule, let's say a very complicated doc rule, that says you have a company on the left and then a receiver over to the right, and then below that there's an inventory rule, and then below to the left we have the financial rule, and then finally there's this legal rule, which is below number 3 and to the right of number 4. In each of these particular rules, these high-level rules, we can zoom in to define them more particularly. So the legal rule would have a preamble paragraph and then some stuff, and then the interesting information that we're looking for, and then navigate it into that place where we get that number that we want. This is a pretty extreme example, of course, because ordinarily you would probably be able to write your legal rule in such a way that you didn't have to understand the whole document in order to get to the right place. As long as you can find enough about that legal area which makes it unique in the document, then you can allow Grammatica to basically navigate its way down, ignoring all the other bits, and then get to that legal rule and read it. If you need to, however, if there is ambiguity and that doesn't work, you can define the whole document. And that kind of gets us to declarative programming. There's just one more feature we need to introduce, which is Grammatica's built-in rules to deal with alternatives and repetition. Very important example of rules which take rules as parameters. So we have a rule called an OR, a built-in rule, an OR, which allows you to write something like this. Company rule could be either the receiver rule or the provider rule or something else. Alternatives are tried left to right, and essentially they produce multiple answer rules, but using the OR as the mechanism for producing those multiple answer rules. The second inbuilt rule is a repetition rule, which we call Q for quantity, and that basically allows us to specify that some rule passed in as a parameter should be repeated from a from number to a to number, and that includes 0. So Q01 find contact basically says don't use the rule at all in the first instance, and use it once if you're asked to try again. Q35 would start by saying you've got to do it 3 times, then 4, then 5, and we could also have as a parameter n, which means go on forever until the rule fails. When the to number is greater than the from number, or it's n, the Q rule basically carries on chewing away until it hits that upper number or the rule itself fails. Just to give an example, with lots of sort of lines in the middle of this thing, if we wanted to capture the data out of here, we would write a rule something like this. The preamble, then some number of lines from 0 to n, and then the stuff or the bit that we want at the end. These are rules which are doing structural work. So we're chewing up the lines one at a time and then dropping into the bit at the end which reads the data we want. When the from number is lower than the to number, the Q rule favors as few instances of the rule as possible. So it starts with the upper bound, and then as you ask it to retry, it starts trimming away more and more of those repeated rules. So if you go from Q10 contact to Qn1 contact, then the rule system will try and find contact as many times as it can It'll then run the subsequent rule, and if that fails, it'll come back and trim one away. So it sort of allows you to go backwards, coming back from the end. For example, if you were given the sentence, this number 10 is more than number 12, then Q0n number would get the number 10, but Qn0, so Q0n word would get the number 10, and the other would get the number 12. That's probably enough to digest in one presentation. So to summarize, rules can have parameters. Parameters can be rules. Rules is Grammatical's inbuilt rules to handle alternatives and repetition. And rules always run within the context that was set up by previous rules. That context being the current position in the document and the content of the Grammatica database. So in the next presentation, we'll put this together into declarative programming.